Hey guys, welcome back. This is Muhammad Badrudra. Hope you all are doing fine. So today I come up with another lab from Web Security Academy from the authentication module. And this module and this lab is going to be very interesting because we will face some kind of encoding, decoding and hashes here. So before going to the lab, as always, this warning for you: this video and its content are only for educational purpose and I do not support any unethical or illegal act. So that's been said, let's jump to the lab. This is the lab. I already open up the Burp Suite. So before going to the lab, I just want to give you an introduction about what this lab all about. So brute forcing stay logged in cookie. Okay. So this lab allows user to stay logged in even after they close their browser session, and the cookie used to provide this functionality is vulnerable to brute forcing. To solve the lab, brute force Carlos cookie to gain the access to his account page, and to check the behavior of that application we have a valid username and password, that is Wiener, and its password is Peter, and another valid user we have is Carlos. Okay, so let's see. You might have seen a lot of time while using some kind of web applications. There is an option stay logged in or remember me, like that. So there is a small box where you need to check it. If you check it, it means you fix that option for you. You enable that option for you to stay logged in or remember me. And after even you close the browser, and after some time, once you come again and you open the browser, you are automatically logged in. So the same thing we are going to see here, but how application behaves and how that application is developed for this functionality, we will analyze that also with the Burp Suite. So I'm going to enable the Burp Suite proxy on my browser, and I'm going to click the My Account page. So once we come to the My Account page, I'm going to see this GET request. And normally, as always, we are assigned a session cookie by the application. And once we click to this My Account, and so the application is redirecting us to the /login path. Okay, so here we get the /login path, and here also we see that there is a session ID. So I'm going to see the response. Let's see what's in the response. So go down. So there are only two parameters as we see here, username and password. And there is one more parameter here, that is for this checkbox, and type is checkbox and its name is stay logged in. Okay, so if we make here, put the username, that is Wiener, and the password is Peter. So this is actually not required. If you check this, okay. If you do not check it, no problem. But if you want that functionality enabled for you, you want to stay logged in, so you must check this box. And once we click login, so we make a post request at that instant, and you can see here we are logged in, and you can see the third parameter here is stay logged in is on, and application redirects us to this My Account page, that is basically this page. And you can see here application also assign us one stay logged in cookie. So we can inspect this cookie, what exactly this is, because if we see this session ID seems normal, but this stay logged in cookie, it seems something different because its length is longer than the normal session ID. So I'm going to open this inspector here, and you can double click this one. So you will find that section here. And because this inspector is very smart, so it detects that, okay, this is base 64 encoded value. So this inspector automatically decoded that value with the base 64, and the decoded value you can see is like this is the username, then colon, and this is something else. So if we count these characters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay, we can do one thing. Instead of counting, I'm going to copy this, come here, I'm going to say echo and paste that, and I'm going to say wc space -c to check how many characters are there. So it said 33 characters because maybe it's including this space. So you can make it uh, like this to exactly count wc space -c 33 really. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Yeah, as expected, 32 characters are there. So these that 32 characters, in my mind, that could be MD5 hash. So we can crack this MD5 hash with there are a lot of tools, online tools. So online MD5, you can go there, or you can search on the Google, you will find a lot of tools. So I come here and I'm going to paste this and just decrypt. So once you decrypt, you will find that this hashed value is actually Peter, means the password of the user. So it means that stay logged in cookie consists of stay logged in cookie consists of what? Consists of username, then colon, and then MD5 hash of password, right? And then this whole bunch of string is again encoded with base 64. Fine. So now, as we know the pattern, we can do anything with that. We can create any stay logged in cookie as we want, because there is no problem to create a string with this pattern, right? So we can brute force this cookie for the Carlos user, and for that we need to do something like this. So same like base 64, then I'm gonna say the user will be Carlos, and then MD5 value of the password, and we will brute force this value. So whatever we take the value from the password list or from the password file, we take one value, put it here, uh, encode it with the MD5, create a hash, then put this script, put this Carlos as a prefix, and then the whole bunch of script, the whole bunch of string is going to be encoded with the base 64, right? So this is very simple. So what I'm going to do is I'm going to log out from here, from the Wiener account, and I am going to take this my account because this was okay. So I'm going to take this one, uh, not this one. Let's see. Yeah, this one, because after login, this was the account page for the Wiener user. So I'm going to send this to the intruder, and I go to the intruder, here I'm going to the position. I do not need everything, so I'm going to clear, and we need to actually brute force this, and inside this whole string we just need to brute force the password, and I will explain that in a minute. So I'm going to add this, go to the payload section, and here to just test what I'm going to do, I'm going to check only the Peter as a winner, whether it's okay or not, it works or not. And in the payload processing, I'm going to add a process, and the first thing is I'm going to create a hash, and that hash is going to be MD5 hash, where it is MD5, this one. So okay, this is the first process. Another process I'm going to add is to add a prefix, and the prefix will be winner with colon. And another thing I'm going to add is gonna be encode everything with the base 64 encode, right? So now go to the resource pool, and one more thing, go to the options actually, and in the options, grep match. So here what I'm going to do, I'm going to clear all of these, and I'm going to add update email, because if the user is logged in, only then this update email string as a button going to come up with the my account page of the user. So I'm going to add this. So if this string is in the response, it means the user is logged in, right? So everything is set up. Let's go and start the attack. Okay, so as you can see, this update email string is in the response. So, and this whole bunch of string belongs to the stay logged in cookie, as you can see here. So if we go to the response, we can see that your username is winner and update email button is there. It means the user is logged in. Now the same process I am going to do with the Carlos user. So I'm going to discard this. Go to the position. Position is okay. Go to the payload. This time I'm going to clear this, and instead of user password, I'm going to uh, load the whole password word list, and these are okay, but I need to edit this because prefix is gonna be the Carlos this time, because we are brute forcing or creating the stay logged in cookie for the Carlos user. So okay, everything is fine. In the option, we already make this match, grep match. So okay, let's start the attack. So this one is nothing, and as you can see, it's generating the stay logged in cookie, and every cookie is different. So what it's actually doing, that okay, we find the password. So I'm going to pause this attack because we already find, and I'm going to explain a bit. So if I go here and I open the password.txt, so what it's going to do, it will pick one password from here and put that password with the first processing rule and create its hash, then add a prefix. So it will be like this. So it's gonna be like this, Carlos colon, and the first password is 123456, or yeah, 56, and then it will create the base 64 string for this base 64. So I will show you. Copy this, go to the buffer, go to the decoder here, paste this, and I'm going to encode this with base 64. So this is gonna be, no, not this actually. So first of all, we need to encode this as MD5. So MD5, this and this. So let's see, copy, come here, MD5 hash. So let's see. Mostly I use CyberChef, but I'm going to. So 1 2 3 4 5 6 create hash. So this is the hash value for 1 2 3 4 5. Copy this and paste it here. Then it will add one prefix that is gonna be Carlos colon this, and then it will take the base 64. So paste, and so this time we need to take this string, copy this, go to the decoder. Instead of this, I'm going to paste this, and as you can see, this is the base 64 value. So if we go to the intruder and if we match this first payload and this is same. So again, next time it will take this password, create its MD5 hash, then add a prefix what you assign here. uh, where is it? Where is intruder? Yeah, what you assign here, add a prefix, then take the encode the whole string with the base 64. So now I'm going here and I'm going to check out the payload. So this is the main string. So I'm going to copy this to see what is actually the password for Carlos. So I'm going to copy this string, go to the decoder, take out this, paste that string, and this time decode that string with base 64. So you can see Carlos and this is the MD5. So I'm going to take this MD5 copy and put that MD5 in the decoder, paste, enter to decrypt chimneys. Where are chimneys? These, this, and this. So let's see. So as you can see, football is the correct password for the Carlos user. So that way we know the exact password for the Carlos user, and even if we do not know the password, we actually logged in. So if we go to the response and I can say show response in the browser, open a new tab, make sure your proxy is on, and paste this here. No, not this. Copy and paste that value, enter, and you can see we are Carlos. Congratulations, we solved the lab. And another thing, because we know the password for Carlos, so we can do like this also. So I'm going to say Carlos and football, enter, and we are logged in. So this is all about the stay logged in cookie, but in real scenario, maybe you will not get that kind of stay logged in cookie because uh, developers or applications uses very good algorithms. Maybe they use AES with the key, so you will not found that much easy, but still you get the idea. So thank you very much for watching this video. Please support if you find this content is valuable. So like, subscribe, and share as much as you can. See you in the next video. Thank you. Bye.